Hello everyone. In this video lecture we are going to study about memory reference instructions available in my basic computer. So in my basic computer I'm having this 7 memory reference instruction. Now how we'll recognize that it's a memory reference instruction? So in my control, if my control unit will generate the signals between D0 to D6, that means it's a memory reference instruction. And if it will generate a signal D7, that means either it is a register reference instruction or input-output instruction. Now each and every signal says that which kind of instruction it is. So if I am having D0 signal, that means it's an AND operation and it will perform the logical AND between the content available in the accumulator and the content available in the memory. And that address, that effective address is available in address register so that we can access that memory, right? Similar way, add operation. So D1 signal, it will perform addition between the content of accumulator and from the memory. And the Cout, that's a carry that would be stored in E, that's my extended accumulator. LDA, that's a load. D2 signal is for that. It will load the data from the memory to the accumulator. STA, that's a store. D3 signal. From the accumulator, we are storing the data from the accumulator to the memory at a particular location, and that location is given in the address register. Then BUN, that will have a D4 signal. BUN, that means branch unconditionally. So if we want to jump from a particular location to a particular location, that means that's a jump. So AR, address register, that address is given to the program counter. Then BSA, branch and save return address, that is having a D5 signal. If you want to complete a particular subroutine and return back to that particular address, so that at time BSA is used, right? I will explain this all in detail. And ISZ, that's increment and skip if 0. It will increment the content of memory, and if it is 0, then it will skip the next instruction. That is having a D6 signal. Now let us see all this instruction in detail. So the first instruction is AND to AC. That means we are performing AND operation between the content available in my accumulator and the memory word specified by the effective address, right? And that is already stored in AR, right? Now you might think that why I have written this D0 and T4, right? So as you know that for AND operation, the signal is D0, right? D0, that D0 specify 0, 0, 0, and the 0, 0, 0 is an opcode for AND operation, right? So that is have been done. And why T4, right? So as you know that T4 is a timing signal, and all my memory reference instruction will start executing from the T4 timing signal itself, right? So from the T4 onwards we'll be having all the memory reference instruction. So at the T4 timing signal, and when my D0 is active, right, D0 is active. So at the D0 T4, the first thing is the memory of address register. That means the effective address, this effective address is available in AR, right? That is my address register. So that will access from that the memory, that means the content. The content is first transferred in DR. Now what is DR? So DR is a data register. Now why we need this DR? So in computer, the arithmetic and logic unit, ALU, is not directly connected with the memory, right? So we cannot perform the direct operation with the memory. So for that we need to first transfer the data into the data register, and then the ALU is connected with this data register, so it can directly perform the operation between the data available into data register and the accumulator, right? So at the D0 T4 signal, first we are transferring my content, my data to the data register, and D0 T5 signal, what we are doing, it is performing AND operation between the data available in the data register and the data available in the accumulator. And whatever the answer it is, that answer is again stored in accumulator itself, right? Along with this, at the same time, what we are doing, we are clearing the sequence counter, right? So resetting the sequence counter, right? So SC would be 0, right? So this is about AND operation. The next operation is add to AC. As its name suggests, it will perform the addition, right, between the content available in the accumulator along with the content that is given by the effective address, that means a memory of AR, right? So memory of AR will hold the data. What AR holds? AR, that's the address register, and address register will hold the effective address, right? So effective address is given in AR, and at that memory I'm having my content. So that content I'm transferring into the data register at the D1 T4 timing signal. T4 is my timing signal, and D1, that's 001, that's a opcode for add operation, right? On the next timing signal, that's a D5 timing signal, the addition is performed between the content available into the data register and the accumulator, and whatever the answer, that is again stored in accumulator. Now if there is a carry, right, Cout, that's a carry, AND carry. So if we are having that AND carry, that would be stored in E. Now what is E? E is a flip-flop of having one bit, right? So that's a extended accumulator, right? E is extended accumulator, right? So whatever the carry it is, that carry is stored in E, right? And again the same thing, at the end we need to reset my sequence counter, right? So this is the add operation. Now next operation we are having, that is LDA. Now LDA, that means load to AC. Now first of all, understand the difference between load and store, right? Load means we are loading the data from the memory to the accumulator, right? And store means we are transferring, we are storing the data from the accumulator to the memory, right? So in the load operation, what it will do, so it will transfer, simply it will transfer the data to the accumulator, right? It will transfer the data to the accumulator. Now we cannot directly transfer, we cannot directly access the memory, right? ALU will have this transfer operation, right? But for that transfer we cannot work directly with the memory. So first we'll transfer the data into the data register at the D2 T4 timing signal, right? And at the D2 T5 it will transfer the data from the data register to the accumulator, and again the sequence counter would be resetted, right? And this D2, right? So D2 is a D2 signal that is having 0, 1, 0, that's a opcode for load operation, right? The same way we are having store, right? Store to accumulator, that means we are storing the data. Store AC, so that means whatever the content is available into accumulator. As you can see, like earlier what we have done, addition is performed and answer is stored in accumulator. AND operation is performed and answer is stored in accumulator. So ultimately again we need to store the answer into the memory, right? So for that we need this STA operation. So STA, what it will do, it will directly store the data to the memory. So that means for that we don't need data register, right? Because a accumulator is directly connected with the memory, right? So at the D3, that's an opcode, right? D3 is a signal. See, D3 is a signal, but D3 represents 0, 1, 1, and that is my opcode for the STA operation, right? And that means at that time the data available in the accumulator will be stored at the address given by address register. So that address is known as effective address. So at that memory that data is stored, and again sequence counter is 0. Right, so I hope you understood this. Right, now next instruction is burn instruction. Now what is burn instruction? Burn means branch unconditionally. So that means it allows the programmer to specify an instruction that is out of a sequence, right? Usually we are having the instruction in a sequence, right? So program counter increment each and every time, right? But what if I want to jump? Right, what if the program want to branch or jump unconditionally, right? That is like, for suppose I'm having 1024, that's the value of program counter. So instead of going to 1025, I want to go to 2041, right? So for that this is used. So simply for that what we do, whatever the address, right, that is available into the address register, that we directly give to the program counter. That means program counter will have that address, and from the next sequence it will go for that address, right? Now there is no need to go back again, right? Because we want to branch unconditionally, no condition is there, right? So that means after that, suppose I'm having that address register is having the address 2041, right? So program counter will have that value 2041, right? And next on it will execute it will increment my program counter, and the next instruction will be performed, that is 2042, 2043 and so on, right? So D4, T4, and again we are resetting my sequence counter to 0. The next instruction is BSA. BSA, that's a branch and save return address. Now what if I want to jump to a particular instruction, right? But after completing that particular set of instruction, I want to return back to the original one, right? So that means it's called a subroutine, right? Set of like instruction, portion of instruction, right? So like this instruction is useful for branching to a portion of the program, right? So that we called it a subroutine or a procedure, right? So when we need to execute a subroutine, at that time this BSA instruction is used, right? So ultimately what it will do, that it will, this is our aim, right? That PC program counter is having some data, right, that I need to store at some location, because store then and only then, if we store that data, then and only then we can return back, right? And then from the next onwards we are having that subroutine. It might be a little bit confusing, so let us see with an example, right? So here I am having, suppose this is my BSA instruction, right, that is stored at the location 20, right? 0 BSA 135. That means 135 is an address where I want to jump, right? And again, after completing that subroutine, I want to come back at this location. That's my next instruction, right? So this is my subroutine, this set of program, right? So after completing this, I want to come back over here. That is my next instruction. Now if this instruction is executing, at that time program counter is having that value 21, right? 20, that's my instruction, that is in the execution mode, right? So but obvious program counter is having 21 value, right? So when the BSA is performed, this 135, that's my location. By default this location is kept blank, right? What's the reason behind that? Because here we can store the return address, right? And 136 onwards I am having this subroutine, right? And that subroutine is having, at the end of the subroutine will have this burn instruction, right? That will jump to this 135 location indirectly. Now what is the reason behind this indirectly, that I'll explain you, right? So this is at the time T4 timing signal, this is I'm having, right? So after execution what it will have, that at this 135 location it will give you the return address, that's a 21, so that is stored over here, right? So what is D5 T4? That's program counter is transferring whatever the data is available in program counter. Here it is 21, so that 21 is transferred at the memory of address register. Now address register is having 135, right? So ultimately it is like that, memory of 135, right? So 21 is transferred at memory of 135. So here 25 is stored at the location 135, right? And then address register is incremented, AR plus 1, that means 135 plus 1, that's a 136, that is given to the AR. So now AR is having that 136 value, right? And at the D5 T5 signal, that AR is given to my program counter. That means program counter is having this 136 value, and here my subroutine starts, right? Now this will give you the instruction, like set of instructions, so it will keep on executing this instruction 136, then 137, 138. After completing the subroutine, the last instruction is bun instruction. Now this is the working of BSA. Now what we have, bun, right? So what bun will do, that will branch unconditionally, so that means it will give the value of the address. What is bun? That is give the value of address register to the program counter. That is the only logic behind bun, right? Now what we are doing indirectly. That means this is AR will not hold my effective address, but instead of that it will have the address of effective address, right? So that means bun 135, it will go to 135. At 135 what I am having, 21, so that value it will give to the program counter. So at the end of the execution of my subroutine, my program counter will again get back to this location, and that location is 21, and so on the next instruction will be executed, right? So it is a little bit confusing, but not that much complicated. If you understand it properly, it is very easy, right? So this is BSA instruction. After BSA, last instruction that we are having, that is ISZ. ISZ, that's increment and skip if 0, right? Now it is having D6 T4. T4, that as you know that all my memory reference instruction will start executing from the T4 timing signal, and D6 signal that indicates the opcode for ISZ, right? Now increment and skip if 0, what it will do? It will increment the data available at my memory that is given by the address. The address register will give the address, right? So that address, at this particular address, memory is holding some value, right? Some data. That data will be incremented, and if that data becomes 0, then it will skip the one instruction. Next instruction it will skip, and if it is not 0, then it will simply execute in a normal way, right? So what we are doing at the T4 timing signal, as you know that we cannot directly increment, ALU directly cannot work with the memory, right? So first we want to transfer the data available into the memory to the data register, right? So data register will hold the value. Now at the T5 timing signal, what we are doing, we are incrementing the data register, right? DR plus 1. So DR plus 1, that means suppose my DR is holding the value -1, right? So -1 plus 1, that would become 0, right? Suppose my DR is holding some value 2 or 3, right? Suppose 2, so 2 plus 1, that's a 3, right? So it will simply increment the data, right? After incrementing it, whatever the answer is, that answer is again stored in DR, right? Now at the D6 T6, right? T6 is the timing signal. At that time, what it will do, it will again update the data, right? Whatever updated data after the increment, whatever the data is, that data is again stored at the location given by the address register, right? So inside the memory, it will update the data. Along with that, it will check whether my DR is 0 or not. If the value of DR is 0, then it will increment the program counter, right? That PC plus 1, that value is given to the PC, that means will increment the program counter. That means that one instruction is skipped, right? But that is based on this condition. If the dr is 0, then and only then we'll do this pc plus 1 and the 1 instruction is skipped. Otherwise it will go as it is, right? And at the end we'll reset my sequence counter, right? So this is increment and skip f0, right? So this is all about the instruction, memory reference instruction available in my basic computer, right? Total 7 instruction we are having: end, add, LDA, STA, BUN, BSA and ISL. So I hope you understood this. Thank you.